Okay, so now let's go over the solution to this football being kicked from the ground. Let's do the steps. Step 1. First, we're going to find the initial components of the velocity, v0x and v0y. So we have 18.0 meters per second is the speed, and it's at an angle of 32.0 degrees. So my components, v0x, will be equal to the hypotenuse, 18.0 meters per second, times the cosine of 32 degrees, and I come up with 15.3 meters per second. v0y is equal to 18 meters per second times the sine of 32 degrees, and that comes out to 9.54 meters per second. Okay, so we have our components, 15.3, 19, and 9.54 meters per second. Now let's move on to step 2. We're going to figure out which direction determines the final time. So remember, the question was how much later does it hit the ground? So this is about height. We want to know, well, it's specifically asking the time when it hits the ground. Okay. And so this will be determined by the y motion. The x motion has nothing to do with how long it will be in the air. Okay. So, final point is reached when we have y minus y0 is equal to 0. Okay. So we start from the ground, we end at the ground. So y minus y0 will be 0. And we're going to solve. Clearly, we're solving the y motion. We solve the y motion equations to find delta t. Okay, so let's take inventory of what we have. We have y minus y0 is equal to 0. We have ay is equal to negative 9.8 meters per second squared. And v0y, well, that's what we got up here is 9.5 meters per second. Okay, what do we want? We want delta t. All right, so we're going to use the equation that involves delta t. Looks like the one we want is we'll use y minus y0 is equal to 1/2 ay delta t squared plus v0y delta t. Okay, so this is going to give me 0 on this side, and then I have 1/2 negative 9.8, and then I'll have delta t squared. Then I'll have 9.54. Let's leave off the units so it doesn't get too ugly. All right, at this point, it looks like quadratic equation time, but interesting thing here is I have a 0 on this side, so I can actually solve this equation without the quadratic equation. I don't have to use the quadratic equation to just get the answer, but let me show you a shortcut. Delta t equals to 0 is a solution of this equation. That's a time when the ball is on the ground, because it starts from the ground. Okay, that's what the equation is telling you. But delta t equals to 0 is not the solution I want. The solution I want is the one that comes after 0. So what I can do is divide everything by delta t, because there's a 0 on this side. This still remains 0, so I'll have 0. So I'm going to divide by delta t. So this trick works if you have a quadratic equation, but there's no constant term. There's no thing that's proportional to delta. You only have delta t squared delta t. You don't have this thing without the delta t. It's 0. So we'll divide by delta t, and what will happen is, let me just simplify this, is minus 4.9, and then one of these will go away and it will become delta t. This, I'm dividing by delta t, and I get 9.54. And I can solve for delta t very simply. It's going to be 9.54 divided by, I'm bringing this guy to here and divided by 4.9, I'll get 1.95 seconds. Okay. So if you have questions about any of those steps, please ask the student supervising this lecture today. Now we move on to step 3. We got the time. The second part of the problem was how far does it go horizontally? So we will use delta t is equal to 1.95 seconds and solve the x motion equations. Okay, so we have no acceleration in the x direction. We have v0x is, now we go back to what we found it before, it's 15.3 meters per second. And delta t is equal to 1.95 seconds. So we want x minus x0. How far does it travel, the displacement in the horizontal direction? That will be v0x times delta t, because v doesn't change. v0, the initial velocity, will be the average velocity, so the displacement is just the average velocity times delta t. And that will be 15.3 meters per second times 1.95 seconds, and that comes out to 29.8 meters. Okay. All right. Now let's do another example. Let's say a ball is launched horizontally from the top of the cliff. If the initial speed is 10.0 meters per second, and the ball travels a horizontal distance of 100 meters before hitting the ground. Okay. How high is the cliff? All right. I'm going to pause the video now. I'll stop the video, and you can start thinking about this problem before I go